Good morning and welcome to Algebra 1 for Thursday, May 14th. Today we're going to go over the prompt that I had given you for homework and do a couple more examples on how we graph from quadratic equations in standard form. So here's the equation I gave you, y equals x squared plus 4x minus 5. I said we start off by identifying a, b, and c. So the a value, please don't say it's x. The a value is never x. It's the number that's in front of x, and when there is no number, it's the number 1. So that's a 1. Our b value is 4, and our c value is negative 5. It's important that you do remember that if there's a minus sign, it's part of that number. Okay. To find the x value of the vertex, we say x equals negative b divided by 2a. And we substitute the values. So we have negative 4 divided by 2 times 1, which is negative 2. So the x value of the vertex is negative 2. Now I have to plug that into the equation to find the y value. So y equals parentheses negative 2 squared plus 4 times parentheses negative 2 minus 5. Again, I'm going to harp on the whole parentheses thing. If you're plugging in a negative value for the purpose of squaring it and you don't use parentheses in your calculator, it will be wrong. Negative 2 squared is 4. Positive 4 times negative 2 is minus 8, and then we had minus 5. 4 minus 8 minus 5 is negative 9. So my vertex is negative 2, negative 9. I'm going to put it right there in the middle of that table because, again, that's where it needs to go, and that identifies the center of my t-table. Then I'm going to move 2 away on either side, so we're going to go negative 3 and negative 4, and then negative 1 and 0. So again, it's in the middle of 5 continuous numbers. In order to figure out what those numbers are going to be for the outputs, I have to plug them in, just like we plugged in the negative 2. I'm going to just go plug in the negative 4, so y equals parentheses negative 4 squared plus 4 times negative 4 minus 5. Y equals 16 minus 16 minus 5, and that's going to be negative 5. I also know that if I plug in the 0, it's going to be symmetric here. It will also be negative 5. It's easy to plug in a 0 here. 0 squared plus 4 times 0, that's just 0, minus 5. And let's also plug in the negative 3s. We get y equals parentheses negative 3 squared plus 4 times negative 3 minus 5. Negative 3 squared is 9. Positive 4 times negative 3 is minus 12 minus 5. 9 minus 12 is negative 3 minus 5 is negative 8. And that's going to also be symmetric, so they're both negative 8s. All I have to do now is, well, graph it. So let's get a coordinate grid up here. We have a lot of negative y and some negative x. I don't really have any positive x or positive y, so I don't need much of that. But I'm just going to do this as my coordinate grid. X has to go 1, 2, 3, 4, to the left, and it's going to go at least 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't really care about the other ends of the axes. Negative 4, negative 5, so 4 to the left and 5 down is over here. Negative 3, negative 8, so 5, 6, 7, 8, so down over here. Negative 2, negative 9, the vertex down there. Negative 1, negative 8. And then 0, negative 5. And again, we just draw the curve, put arrowheads on both ends, and we're good to go. This parabola opens up, making its vertex a minimum. It's decreasing to the vertex and increasing away from the vertex. The key to also understand whether or not the parabola will open up or down is the leading coefficient, the x squared. A is positive in this problem, so it opens up like a smile. It's a positive number, it smiles. If it were a negative number, it's going to open down, and negative people frown a lot. I know that's very childish, but it's a way to remember it, okay? Positive leading coefficient opens up like a smile. Negative leading coefficient opens down like a frown, and that will always be the case. Okay, I'm going to give you another problem here, but one that hopefully will answer some future questions about what happens to certain values. So I'm going to say y equals x squared minus 4. Okay, so the first question is, isn't something missing? We're used to seeing three pieces, the x squared, the x, and the constant. I don't have the x piece of the equation. There's a really good reason for that. Identify your A, your B, and your C. My A is the coefficient of the x squared. It's the number 1. My B is the coefficient of the x term, which is missing, so it's the number 0. C is negative 4. A missing term isn't really missing, it's just been multiplied by 0. So that number, whether it was B or C, is a 0. Remember, A can never be 0. A could be anything in the world except 0, because if it were 0, it's no longer a parabola. There's no curve to it. Okay, so now I have my three numbers, one of which is a 0, and I do the same thing I was doing all along. X equals negative b over 2a. That's negative 0 over 2 times 1. Well, 0 over anything is 0. So the x value of my vertex is 0, which makes the rest of this even easier, because 0 squared minus 4 is just negative 4. So my vertex is at 0, negative 4. So when you make your t-table, that goes in the middle, 0, negative 4. Almost didn't put a negative again. And we want to put the two values below and above, so negative 1, negative 2, positive 1, positive 2. Because 0 is the x value of the vertex, this table of values has the 0 in the center. All right, now we can plug in numbers and go from there, but here's something even easier. Positive numbers are easier to square than negatives because you don't have to worry about whether you get a positive or a negative number. Let's just use some mental math for a second, okay? Use the number 1. What is 1 squared? 1. And 1 minus 4 is negative 3. So when I plug in a 1, I get a negative 3, which will be symmetric on both sides of the vertex. Now plug in a 2. 2 squared is 4, and 4 minus 4 is 0. So when I plug in a 2, I get a 0, and that's going to be symmetric on both sides of the vertex. My table is finished. I didn't even have to do any more work on paper because a little mental math is not a bad thing when you can handle it. And if you can't, there's always the calculator or some careful math on paper. So when I go to graph this, which is not too hard to do now, I need some negative y and positive and negative x. So I'll go 1, 2, 1, 2, 1, 2, 3, 4. I don't need any more than that based upon my numbers. And let's graph it. Negative 2, 0 is right there. Negative 1, negative 3 is right there. 0, negative 4. 1, negative 3. And 2, 0. And I get my parabola, and I am done. Okay? I know I've been doing a lot that open up. It's just an easier example. But that's an example of what you do when the b value, the x term, is missing. And why not? Let's do one more fun example for you. This time, let's say it's y equals, so I probably should do a negative one for you, right? Negative x squared minus 2x. Okay, Well, I have an A. What's my A? -1. I have a B, because there is an X term this time. My B is -2. This time my C is 0. There's no constant, which is fine. We'll see later on what those numbers actually do to the equation, but it's okay if there's no C, it's just the number 0. Because I'm still going to do the same thing, x equals -b over 2a, that's -2 divided by 2 times -1. Boy, there's a lot of negatives here, but be careful with them because -b just means it's negative whatever b was, and in this case, b was a negative number. -2 is 2, and 2 times -1 is -2, so my x value of the vertex is -1, and now I plug it in. Be careful with negatives. Negative parenthesis, -1 squared minus 2 times -1. Again, tons of negatives here, but do the exponent first. So that's negative parenthesis 1, and then -2 times -1 is positive 2. Now, negative times 1 is -1, and when I add 2, I get positive 1. So my vertex here is the coordinate -1, positive 1. Now that I have that written down, I can make a t-table. Just going to clear it out. So my t-table has -1, 1 in its center. Moving back twice, I get -2, -3. Moving forward twice, I get 0, 1. And again, if you want to use mental math, you can. With negatives, it can be a little trickier, so be very careful. I'm not going to use mental math here. I want to show you how to do it right. So negative parenthesis, -3 squared minus 2 parenthesis, -3. Because I'm going to use -3 for x. Okay, well that's -9 plus 6, which is -9 plus 6. So I get -3. So when I have an x value of -3, the y value is also -3, which will be symmetric and also occur down here when x is 1. And now I'm also going to do the -2. So negative parenthesis, -2 squared minus 2 parenthesis, -2. That's negative parenthesis 4 plus 4. That's -4 plus 4. Well, that's 0. So I get a 0 here and there because it's symmetric about the vertex. And now I can graph it. And again, you could use a graphing calculator if you wanted to double check. For the table, you could use Desmos if you want to see what the graph would look like. It's not a problem. But I have some negative x and a little positive x, some positive and negative y. So I'm just going to make a standard grid. 1, 2, 3, 4 on all sides, just to give myself more than enough room. -3 plots over here, -2, 0, -1, 1, 0, 0, 1, -3. And here's my parabola. This one opened down, which means the vertex is the maximum. It increases to the vertex and then it turns around and it decreases away from the vertex. Why was it opening down? Because the leading coefficient was negative. The a value was negative, which makes the parabola, we say, reflect over the x-axis, turns upside down. So instead of opening up, it opens down because the a value was negative. Okay. That's all the examples I actually want to give you today. There is a worksheet that's attached to the Google Classroom announcement for today with a very small number of problems for you to practice graphing from standard form. All right, please do them and submit to me a picture of your finished work no later than tomorrow by 10 a.m. Have a wonderful day.